Hello everybody. I would like to thank the organizers for their very kind invitation. I'm very pleased and honored to be here. I must say that I also feel a little bit impressed because in our usual scientific conferences we are not used to such a large audience. So, as you mentioned, I am not a room acoustician, so I work on product sound quality by my co-author Patrick Chevret, you can see here, called me and suggested a cooperation in this field of open plan offices. So next, perfect, okay. So the starting point is, as Nigel mentioned earlier this morning, noise is a major source of discomfort in open space offices. And we started some basic research, so maybe you will not find any practical application just now, but hopefully in the next few years. And this research was organized in 3 points. First of all, as you said, the development of an assessment questionnaire for people working in open plan offices. And then we investigated the influence of some noise parameters through laboratories experiments, because in a laboratory you can finally control the sound parameters. And then Patrick recently proposed an improvement of existing sound metrics. So I would like to give you an overview of these 3 points, and then finally you will be allowed to go to lunch. Hopefully. Okay, the questionnaire first. So the goal was to provide to practitioners an easy way to evaluate comfort in existing open plan offices. So this questionnaire was developed using many existing studies about satisfaction at workplace, noise sensitivity, because I think Nigel also mentioned this. There are some extra auditory factors to noise annoyance, and noise sensitivity could be one of these factors, and also self-assessed health. So there are 4 main parts in this questionnaire. First of all, some general information about the respondent, his gender, his age, his seniority, his position in the company. And you see, is there a laser pointer? No? Okay, so you see, oh yes, just close here. Thank you. You see here this part of the questionnaire, so sorry, German regulations are in German, and French questionnaires are in French up to now, but we also hope that it will be translated in English later on. So this part of the questionnaire about the respondent, and then a few questions about his satisfaction, his general satisfaction, according to 2 main points. The first point is control privacy. Does he feel that he can control his environment? And the second point is more about basic comfort, the furniture, the lighting, and so on. And then we focus on the noise environment, an overall assessment about the noise environment, and then focus on 5 main sources, which appear to be the only sources we can find in open plan. Sound from machinery, printers, heaters, and so on. Ringtones, intelligible speech, and also non-intelligible speech which we can call the speech bubble. And then the footsteps, people passing in the office. A third part is devoted to the relation to noise. This is a reduced version of a classical questionnaire about noise sensitivity. And then the fourth part about the health as perceived by the respondent. It's sometimes difficult to ask companies it's sometimes difficult to spread this part, because companies now, in France at least, don't like that very much. And this is also based on a previous questionnaire developed at INRS. Altogether, this led to 67 questions, so a rather short questionnaire. And there is a paper on an internet version. And if you want a more detailed presentation of this questionnaire, you can look at this paper, which was published last year in Ergonomics Review. Just a few results. Up to now, we have collected about 600 questionnaires in 23 workplaces. So, okay, this is not a big news, but it's just a way to prove that this questionnaire seems to work. This is the relation between noise annoyance and the general satisfaction at workplace. So noise annoyance, the answer is a 5-level scale. So in this here, people are not annoyed by noise, and here people are highly annoyed by noise. And for people responding in each category, we also draw some histograms of average answers according to the general satisfaction. So it's an average, so the numbers are not integers. On high satisfaction, on a low satisfaction. And okay, as could be expected, if people are not annoyed by noise, they are rather satisfied, generally satisfied in their office, and the satisfaction decreases as noise annoyance increases, and the correlation is significant. Also, the most annoying sources seem to be the intelligible speech. So the level, here the scale is from 1 to 4, and you see here that speech, intelligible speech, is significantly more annoying than all the other sources. We also asked a specific question about telephone conversation, because we wonder whether listening to a half conversation could be more annoying than listening to a full conversation. And no, the answer is no. A phone conversation is not more annoying than a real conversation at the workspace. Okay, so once again, these results are not very new, of course, but the point is that this questionnaire can be used, and it can be used to evaluate the annoyance in an existing office, and then after hopefully doing some improvement of the office, you can ask people to fill the questionnaire again, maybe a few months later, in order to evaluate the effectiveness of the modifications you made in the office. It's okay? Yeah. The second point of our study is about laboratory experiment. The question is, can we conduct laboratory experiment to investigate the influence of noise parameters on annoyance? Thank you. So an example of a study we conducted is the relation between speech transmission index and annoyance, and performance, sorry. I guess you know this very known picture taken from a paper from Vittorio Ongisto 10 years ago. And he collected results of previous studies in which people asked subjects to do a specific task while being exposed to a noise, whether more or less intelligible speech. And Ongisto proposed a model relating the speech transmission index as an indicator of speech intelligibility to a decrease of performance. And we wanted to work a little bit on that by adding some new points in the intermediate range of the speech transmission index, namely between 0.25 and 0.65. So the experiment is a very classical one. The subject is seated in a soundproof booth in front of a loudspeaker emitting some noise, and he has to achieve a task according to what appears on the screen of the computer. So we used 5 noise stimuli: bubble plus unintelligible speech, and we varied the value of the speech transmission index from 0.25 to 0.65, while keeping constant the overall level of the mixture to a level of 46 dBA, which is a typical level of a rather good open plan office. And the subject was exposed to each of these mixtures during 10 minutes. And we also added a controlled situation, which means a silent situation. And during each of these 10-minute sequences, the subjects had to achieve a very specific task. The problem is that in laboratory experiment, if we want to be able to measure something, we have to ask people to do a very specific task. Otherwise, the performance is always very good. People really can tackle with adverse conditions. So we use the classical procedure, which is called the serial memory task. The subject had to recall a series of 9 digits, 1 to 9, which are randomly ordered. So let's try together this task. So I need your full attention. So this is exactly how it works. Okay. So imagine that you have to recall this series of digits while listening to me. Okay, and then a 5-second pause, and then you have to write down this exact series of digits. And then again and again during 10 minutes. It's a rather boring experiment. I wouldn't like to do this. I prefer to be the experimenter. Nevertheless, we asked 57 people to do this, and we found 57 people who agreed to do this, and not only students. No? And we found results which are more or less in lines with the picture from the drawing from Ongisto. If the speech intelligibility increases, the performance decreases. Performance here is a decrease in performance in the number of correctly recalled digits in this situation minus the number of correctly recalled digits in the control silent situation. So the increase is what we could expect. But the funny point is that in our panel of 57 people, clearly there were 2 groups of participants. Some of them, I call them high-performing participants. They made very few number of errors. And whatever the speech intelligibility, this number of errors was very low and very close to the control situation. And another group of people, the low-performing participants, in average, they made more errors than the first group. And these people were very sensitive to the speech intelligibility. The decrease of performance is higher for higher level of speech transmission index. So our problem, I think, is that we have to tackle with this very large variability, inter-individual variability. And in many experiments, people use a small number of people. So depending on the sampling of these people, the results can be very different from one publication to another one. So this is a difficult point for us. Okay. We also asked people to estimate themselves the cognitive load to a very well-known another questionnaire, which is called the NASA Task Load Index questionnaire. And also, the high-performing participants seem to be less annoyed than the low-performing participants, even if they relate a higher annoyance when they hear the speech than in the control situation. So maybe a good idea is to mix together performance measurement and self-evaluation of annoyance in order to understand what people feel while doing the experiment. Okay, the third point is related to sound metrics. So in open plan office, how can we measure the noise exposure for people? We can use equivalent sound level, but we know that this level can be very low, rather low, while people still complain about noise. And the other metrics describe the empty room, the acoustics of the room, the reverberation time, some distance, privacy distance, and so on. But I think there is a need for some additional metrics which can really describe the actual noise exposure for people working in an open plan office. And we know that speech intelligibility is a detrimental factor to comfort and increases with the modulation of ambient noise related, and this is related to the number of people working in the office. So Patrick Chevret, my co-author, proposed an additional matrix which is the temporal fluctuation of noise level. So namely, it's the difference between the averaged level and the short-term level calculated over 125 milliseconds, and we detect the value exceeded during 90% of time. So we have two examples here of recordings in different offices. This is a very stationary noise, and this is a highly modulated noise. So this can indicate that there are lots of people talking in the office, because we know that speech is a modulating noise. So this indicator can represent a high proportion of speech in background noise, and we know that also that a modulated background noise is less effective to mask speech from close coworkers. This is the deep listening effect. So for these two reasons, we assume that this indicator could really describe the noise exposure. So this is the very beginning, but in some of the 23rd workplaces in which people filled the questionnaire, Patrick Chevret could do some measurements, and you see here the mean noise level and this modulation indicator. And of course, when the noise level is high, people are highly annoyed. This is not surprising. When the noise level is low, people are not that annoyed. But when the noise level is low and the modulation is high, people can be annoyed too. So this can be a good additional metrics to represent the exposure. So this is my conclusion. A questionnaire has been developed. It will be included in a few French standards, and I think that Johan Lemuet will present the standard tomorrow afternoon. To some extent, laboratory experiments can reproduce in situ results, and this is very helpful for us because they allow to really work on some controlled stimuli and to understand the cognitive effect. And some relevant metrics should be used to describe the actual noise environment. This was not the last slide, sorry. I just would like to mention two unanswered questions. The first one is, do people complain about noise because really noise is annoying, or because they miss some privacy, so that they express their dismiss by complaining about noise? I really don't know if we are very clear about this point. And a second point is, in laboratory experiment, how can we deal with inter-individual variability and use more realistic tasks? Because remembering a sequence of digits is not very realistic. Thank you very much for your kind attention.